Okay, day one, we're going to look at solving quadratic equations. First method we're going to look at is by factoring. So generally, if something factors, that's the easiest way to solve the quadratic. You have to bring everything to one side, get it set equal to 0. Factor. So we want what multiplies to positive 15 adds to negative 8. So that'd be a negative 5, a negative 3. This is where then you tee it off. If two things multiply to 0, then we know at least one of them is 0. So x could be 5, which would make that 0, or x could be 3, which would make that product 0. X minus 5 times x minus 3. Okay, the next one, first thing I would probably do if I were factoring here is pull out the GCF, which is the 7. Then you could divide both sides by 7. And you would get x squared minus 2x plus 1 equals 0. You can only divide if you're dividing by a constant, a number, without a variable. You can never divide by a variable, because then you would be dividing by 0. Could be dividing by 0. We want what multiplies to positive 1 but adds to negative 2. So 1 and 1 are the only thing that multiply to 1. If it's negative 1, those add to negative 2. So this would be x equals 1, x equals 1. So really, we could just say x is 1, right? It is a double root. It occurs twice, but basically our answer is 1. I could either circle them both, or if I was doing it in a solution set, I would just say x, basically the solution set is 1. Okay, same thing with the next, bring everything over. This is one of our trinomials where the leading coefficient is something other than 1. It's a 2x squared. So I need 2x and x. 3 factors of 3 are 1 and 3. And I want them in this order so that outers gives me 6x, inners gives me 1x. Those will add to 5 if I make the 6 positive, the 1 negative. 2x minus 1 equals 0. X plus 3 equals 0. X is 1/2. X is negative 3. Now, the number 4 here, a common mistake people sometimes make when it's factored is they want to just go right to teeing it off. You could only do that if it's equals 0. If it's not equals 0, then you have to distribute through, move the 6 over, then get it set equal to 0. Now you can factor and solve. So sometimes people think they could just break it into factors of 6. No, you can't do that. Okay, so 3x and x give me 3x squared. Only thing that multiplies to 3 is 2, or to 6 is 2 and 3, or 1 and 6. We try the least extreme first. I'm going to put the 2 here and the 3 here, because then outers would give me 9x, inners would give me 2x, which would add to negative 7 if you make it a negative 9 and a positive 2. And the lasts will still multiply to negative 6, so I want to make sure that that is the case. Otherwise, I don't know if I have it factored correctly. 3x plus 2 equals 0. X minus 3 equals 0. This is x is negative 2/3, and this is x is 3. So those are my answers. Now there's another method that is solved by extracting the square root. It's not that, you couldn't necessarily do it, by factoring or, some of the other ones that we'll talk about or quadratic formula, but we're going to look at solving this one by extracting the square root. And the reason is, like in number 5, if you can isolate the x squared, if like there's no x term, so if you just have constants and an x squared, the quickest way to get your answer is to, subtract the 4. Actually, let me show that. Subtract the 4 from both sides. 3x squared equals 126. Then we would divide by 3. So we're going to isolate the x squared. We're going to get the x squared by itself. That divides evenly to 42. And then we are going to square root. When you square root in an equation, you need plus or minus. That's your answer. So I should say here, isolate the square first. So the first thing you do is isolate the square. So if I were doing this next one, I would add 2 to both sides. Then I would divide by 3. Then I would square root. So x plus 7 would be plus or minus radical 8, which is 2 radical 2. And then I would subtract the 7. So that's my answer. So you isolate the square, then you square root. Now, some people would say, well, couldn't we have FOILed through the x plus 7? Yes, you could have FOILed it through, got everything to one side, factored, or if it wasn't factorable, which this one would not have been because it's irrational, then you would use quadratic formula. But we were looking at the taking the square root method. Now, third type is completing the square method to solve. So there's some steps here. We move the constant over so that we have ax squared plus bx equals c. So we move the constant over on the right. Then we take half the b, square it, add that number to both sides. That's the completing the square process. Take half the b is the coefficient of the x, square it, add that number to both sides. Third, we write left side as a binomial squared. And then simplify right side. And then last, take square root and solve. So then it kind of becomes a problem that we were just doing where we take the square root and solve. So let's look at this. We group the x squared and the x. I'm going to leave some room and I'm going to move the constant over. So that's step 1, move the constant over to the right. Then we're going to take half the b. So half of 6 is 6 halves or 3. We are going to square that, get 9, and that's what we're going to add to both sides. Then we write the left-hand side as a binomial squared. Notice the left-hand side is something we were just factoring in the last unit. which is called a perfect square trinomial. We said a perfect square trinomial can be written as a binomial squared. The trick to getting that is you always put half the b inside the parentheses. So the b was a +6, we're putting a +3. Simplify the right side. That's what it says up here for step 3. Simplify the right side. And then now it looks just like the last examples we were doing, where we take the square root, x plus 3 equals plus or minus radical 13. Move the 3 over, -3, -3. So -3 plus or minus radical 13. Standard form is to write the integer first and then plus minus the radical. So that's why I'm writing it that way. So the next one, move the constant over, take half the b, half of 5 is 5/2. Square it, that's 25/4. Now, people are often tempted to put that as a decimal. Do not turn it into a decimal. Leave it a fraction, and you'll see why in a minute. So now here, it's just half the b that goes inside. Half of 5 is 5/2. We already figured that out up here. For here, I'm just going to get a common denominator. So 9 is 36/4, making this 61/4. And then notice when I square root, plus or minus, that's radical 61 over regular 2. Square root of 4 is 2. So that comes out of the square root. And then move the -5/2 over. And that's your answer. Since it has a common denominator, or you could say -5 plus or minus radical 61 over 2, it doesn't matter to me, whichever way. So either or is fine for your answer. Now, in the next one, all right, the left-hand side is fine. On the right-hand side, we have to simplify, and I have to follow order of operations. So I have to distribute the -x. And I'm going to get everything, well, actually not everything, but I'm going to move the 2x over. The 7 I'm going to move on this side. So let's look at why I'm doing that. That way I'll be left with it how I want it, which is ax squared bx on one side, the constant is over on the other. Now, here's the problem. One thing that you have to know, just going to give myself some room here, is you cannot complete the square unless the leading coefficient is 1. So in this problem, a mistake a lot of times people would make is they would start to try to complete the square. They would try to take half a -8, square it, add it to both sides. You cannot do that because of that 3. That 3 has to be a 1. So what I would have to do is I would have to divide by 3 so that I get the leading coefficient to be 1. So 3 divided by 3 is 1, 8 divided by 3 is 8/3, 10 divided by 3 is 10/3. Now I'm going to take half of the b, So half of the negative 8/3, which is negative 4/3, square it, that's 16/9. 16/9 is what I'm adding to both sides. So half the b goes in parentheses. On the right, I'm getting a common denominator. And now I'm ready to square root. Radical 46 over regular 3. And then when I move the 4/3 over, it's 4/3 plus or minus radical 46 over 3. Finally, solve by quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sometimes it helps in the beginning to identify what a, b, and c are. So a is 1, it's the coefficient of the x squared. B is 8, c is negative 2. So x equals negative b plus or minus the square root. I usually automatically do b squared. So 8 squared is 64 minus 4ac all over 2a. This is 64. Now minus 4 times minus 2 is a positive 8. So I have a radical 72, or I have, 72 under the radical. Now, some mistakes I see people make at this point. I'm going to put this over here. This is incorrect. I see people that try to cancel those and then they break down the radical. No, this negative 8 is divided by 2, but so is the radical 72. So sometimes people just try to slash those out and then break down the radical. That is not correct. So what you want to do is first break down the radical 72, 36 and 2, which is 6 radical 2. Now, if you're dividing each of these by 2, then you're going to, 2 divided by 2 is 1, 6 divided by 2 is 3, negative 8 divided by 2 is negative 4. So you have to take the 2 out of every integer. So you get negative 3 plus or minus 3 radical 2 over 1. You do not have to write because dividing by 1 gives you the same number back again. So that's more simplified, the way I wrote the answer. All right, here a is 2, b is negative 3, c is 1. So x equals negative b, which would be positive 3, plus or minus the square root. B squared is 9. Keep in mind that first number is always going to be positive because it's b squared. It's always going to be a number squared. So you square a negative, it's positive. So, and then minus 4ac all over 2a, which is 4. 9 minus 8 over 4. Let's give myself some room here. This is 3 plus or minus radical 1 over 4. Now, I often see people leave that as their answer. No, that's not the answer. That's not simplified. Square root of 1 is 1. So that simplifies to 3 plus or minus 1 over 4, which then, since I no longer have a radical, I can actually simplify that. 3 plus 1 over 4, 3 minus 1 over 4. This is 4 over 4, which is 1. This is 2 over 4, which is a half. So my answers are 1 and 1/2. I'm writing that as just a set notation. I do not have to write it like that, but that's why I'm using brackets. Do not use parentheses because then it would look like interval notation, or you could just say x is 1, x is a half. Those are your two answers. Okay, that's it for day 1.